All right, lots of stuff to talk about today. Let's blast through it, starting with coronal mass ejections, which are directed toward, well, we're not telling it yet. First thing we're doing is looking at the sun's colorized magnetogram. Now, to many people, stars are the magnetic fields. Certainly the magnetic fields give us incredible insight into their activity, whether it's coronal hole behavior or sunspots. We've got two of those right now. Sunspot 2841 down here. Still beta class, still capable of producing C-class flares. Sunspot 2842 up here, quite large. Pretty stable. They've both remained pretty stable in the past 24. 2842 is an alpha class sunspot though, so the likelihood of major flares from it is a little bit lower. Let's take a look at the point of view from Lagrangian point 5, the location of stereo A. As we see massive amounts of missing data, volumes of it, and a coronal mass ejection. All I'll really say about this one is it is not directed toward the Earth. Even if you see a halo-like projection from the perspective of Lagrange point 1. So looking at Lagrange point 1, here's the view from the LASCO C2. And we see some non-Earth-facing coronal mass ejections. Also at Lagrange point 1 is the LASCO C3, the other coronagraph on the SOHO spacecraft. And you can see some halo-like ejecta there. Again, I assure you, there's been no coronal mass ejection on the Earth-facing side of the Sun. We would have probably forecasted it. Continuing on, here's some more imagery of the closest star here. This is 304 angstroms ionized helium, and up here is where that coronal mass ejection came from. It came from an old sunspot, which is no longer even Earth-facing. And when we say keep an eye on the Sun, well, some of us are doing a pretty detailed job of this. And shout out to Eugene Bagashov, who's been doing some interesting science about the location of major solar flares. That 304 angstrom imagery there is just the past 24 hours. And here's a little more spectacular imagery. This is the colorized magnetogram in 171 angstroms ionized iron. And it's for the exact same time frame. That's why we've truncated the time and date stamps. There's a great equatorial view. As I am not only smAsho, I am also a client. And we like people to know where things are, so here's some astrography. Yes, astrography. Here's where stuff is now in the solar system. There's where things will be in 1 week. The 10.7 centimeter radio flux is now at 74 solar flux units. That's the radio output from the upper chromosphere and lower corona. It's the most proportional data set there is to sunspot number. There are the comparative charts. The black line's the radio flux, the red line is the sunspot number. Again, only at 74 solar flux units. We are expecting some geomagnetic unrest conditions here. Mainly tomorrow and early in the day on Wednesday. So there you go. There actually was a forecast for geomagnetic unrest early this morning. I don't think that arrived. Extremely low solar wind speed. We're going to get a heck of a signal. Before we get into more of that, let's look at global seismicity, as earthquakes are sort of important. Here's the massive earthquake drought that's going on. Check it out. Only 1.7 magnitude earthquake in the past 90 days. Let's check the list from USGS. And I would remind our viewers once again, if you're in an earthquake-prone zone, please have an earthquake plan, as earthquake droughts end in large earthquakes. So barely even seeing anything in the 5 range. Quite a bit of activity here on the west coast of the U.S. once again. I think that's the largest quake of the past 24 hours, a 5.0 magnitude in Peru at over 128 kilometers estimated depth. Alaska also saw 4.9. Shout out to Brett if you felt that one. So really it's an earthquake lull, folks. It's enough of an earthquake lull that if you hear that rumbling sound in the background, That's because we decided to go to warp here at the Smash bunker. We've left Earth entirely, and now we're broadcasting from another dimension. Also a deep quake in Indonesia there. So a major earthquake lull, folks. It's the quiet before the storm, as the earthquake 7+ magnitude drought continues. Let's see what volcanoes have been erupting, and Karimsky remains on the list. It was there yesterday. It's still exploding. It's still producing a 10,000-foot plume of volcanic ash. Abiko also. Similar-sized ash plume there on Paramushir Island. Flight level 100. 10,000-foot plume of ash. Suminosejima, 12,000-foot plume of ash above it. In the Ryukyu Islands, Dakono on Halmahera exploding. Flight level 070 there. Popocatépetl exploding. Flight level 190 there. It's a 19,000-foot ash plume over central Mexico. Fuego producing a 15,000-foot ash plume over Guatemala as it explodes. Sangay and Revenador, the two Ecuadorian volcanoes, are both exploding, producing a 20,000-foot and 14,000-foot ash plume respectively. That's Sangay and Revenador in the country of Ecuador. Also, Sabancaya down in Peru exploding. Continuous ash emissions have produced a 25,000-foot plume of ash. Please do not attempt to pole vault it or any active volcanic caldera. In fact, maybe don't even try to pole vault caldera, period. It seems like an inappropriate use of your field skills. This public service message brought to you at massive personal risk and expense by smAsho.com. So please support the channel via the links below the video and the other links that maybe aren't below the video but are at smAsho.com. smAsho.org will redirect you. And don't forget to press like and subscribe if you're viewing on wherever you're viewing. Leave a comment. Tell your friends and foes about the channel. Let's check the instruments facing the sun on the GOES 16. And we saw a minor flare happening here, just threatening the B-class range while we did show prep. A mild little roll of X-rays. Pretty low levels of activity here. We could see C-class flares once again, most likely to come out of sunspot 2841. No proton strikes, no coronal mass ejections have been headed our way recently. We would have let you know. Here's the GOES magnetometer over the past 3 days. Seeing pretty high highs and high lows at the moment as the North Pole current sheet approaches. Here's a view of that. Keep in mind, this is not to scale. And the data is derived from magnetometers on the ground, about 51 of them here on planet Earth. As well as at Lagrangian point 5 stereo A and Lagrangian point 4 stereo B. And you can see this green area, that's the North Pole current sheet, headed our way. Here's the line of sight ecliptic plane field plot, showing you a three-dimensional view from a more earthly perspective. And here's the line of sight coronal hole plot. You can see that large red area there. That's the coronal hole that's expected to produce some geomagnetic unrest in the coming couple of days. Here's another view of that coronal hole. Now only showing south pole polarity. It showed some confusion a couple of days ago when it was over in this portion of the sun. And we're wondering if perhaps it's associated with Terminator events. I won't get into it. Anyway, there are your detected sunspot groups as well. Sunspot 2841 remains beta class. Again, likelihood of solar flares a little bit higher as a result of that magnetic complexity. KP index at 1. And for you new viewers, thanks for tuning in. The KP index is a measurement of global geomagnetism. Next, the real-time solar wind. To see a very low solar wind speed and the leading edge of a coronal hole wind stream. So here's the density spike at the beginning of a coronal hole wind stream. Now up to, well, the density spike is subsiding, so we're going to see the solar wind speed come up here soon, I would suggest. And we do see the BTBZ and the phi angle here starting to shift at the same moment that that high density coronal hole wind comes in. Anyway, current conditions still very low for the solar wind speed, below 300 kilometers per second. Solar wind density now 16.89. We can expect to see this. We can expect to see the solar wind velocity jump up here quite soon as the solar wind density drops, the signature of a coronal hole wind stream. Let's check the geospace. Here's the space weather modeling framework for what's going on around planet Earth in terms of magnetohydrodynamic pressure. And it's pretty steady here. You may see the pressure drop off a little bit at the end as the solar wind density has just recently dropped down. And you can see a tiny reduction there in the pressure on the bow shock region, the portion of the planet facing the sun. Here's ground magnetic perturbations. We show 4 hours of this data daily as well on the DSW videos because there's a geomagnetic excursion going on. And please leave us a comment if you're very scared and spooked because of listening to alarmist fraudsters on YouTube. Anyway, that's 4 hours of data. Geospace delta B changes to Earth B field, otherwise known as ground magnetic perturbations. By the way, if you haven't checked us out on Twitch, you may want to download the mobile app. It'll actually alert you when we go live and so on. Twitch.tv/smAsho is the site of lots of live streaming from us. We'll be doing it again today. And if you're viewing the videos on YouTube, don't forget to press like and subscribe. Press the share button. Tell your friends and foes about the channel. We need your assistance because the algorithms are trying to murder us. Also, we've recently put up some exclusive content. Oh, don't forget to check our playlists as well. There's playlists with all kinds of stuff, such as aquarium videos. Were you aware? Look, it's James T. Kirk. Anyway, go have a check. Go have a look at that. YouTube.com/smashamash/playlists. And because of the algorithms, we've created a Patreon account. So if you'd like to support our channel that way and get all kinds of benefits nobody else gets to see, patreon.com/smashamash for early updates, multimedia, other science stuff, nutritional stuff. In fact, we just put up a post today for our condensed matter to the 9th power tier patrons about what supplements I take. More on that at a later time, but the condensed matter tier gets stuff before anybody else. Anyway, there are a bunch of tiers over there. Thanks again, patrons. If you haven't checked us out on BitChute, you may want to check that out. We've just recently surpassed 500 subscribers over there. And by the way, we get many times as many views on our BitChute videos as we do on YouTube. So for instance, that meteorology segment there received 600 views, that one 630, and so on. Many more views on BitChute. We just recently did a 500 subscriber special, a BitChute exclusive. Here's a clip from that. To use it in a sentence, I Googled it, and now I know less about it. Anyway, I'll just leave that there. You'll have to go to bitchute.com/smashamash to see that exclusive. Also, you're all invited to check out our Discord chat. This is going to become more and more active over time. Our Discord chat, there's a link to that on the homepage. So head to smashamash.org, smashamash.com. Right there is the invite. You need an invite to join a Discord chat, and there is the permanent link right on our homepage. Also, check out our merch. Today's featured merch is the Essential Google Bias shirt. Yes. Now, I'm currently wearing one, and mine is in red. Why? Because the censorship has got to stop. Anyway, there it is. If you're still using Google as a verb to mean anything besides to obtain biased search results about someone or something on the internet, that's what the word actually means. Let's use it in a sentence. I Googled it, and now I know less about it. Today's cosmology segment will be integrated into the daily space weather video. So let's do it. And we're going to talk about the astronomy picture of the day. So this is a pretty good one. It's known as the Dumbbell Nebula. Don't be a dumbbell. Know what's going on in the nebula. And I'm going to actually mark this up for once. And what we're seeing here is a nebula, and it's showing us a great indication of where the torus and where the poloid is located. So if you see these ray-like features right here, notice how they're opposite each other? This gives us insight into the precessional wobble of this star. So the star's axis is wobbling about this much. And that's why this is such a violent place, because this star has an extremely significant precessional wobble. Now, all rotating objects precess. Precession is like the wobble of a spinning top. And stars and galaxies all precess. All rotating objects precess because they're never perfectly symmetrical and there are forces acting upon them. So that's part of what's going on there. And you can see the torus is extremely distended. And of course, the mechanism behind what's causing this extreme precession and so on is not understood. What you're looking at here is oxygen and hydrogen. So is it a surprise that you see lots of hydrogen coming out of the star's poles? And you see lots of oxygen around its torus? Probably not a coincidence. But that's the shape of things, folks. In other words, this star is rotating in this fashion. It's rotating on this plane. And its precessional wobble is what is creating these features. In other words, its axis is wobbling in between this range. Back and forth, and that is why you see these ray-like projections, because those are the poloidal outputs coming out of the polar jets of that particular star. Anyway, that's M27, the Dumbbell Nebula. It's named for Charles Messier, who was looking for blurry objects, which are not comets. And he had no idea that what he was looking at was largely galaxies, but also nebulae inside the Milky Way. Now, yesterday's cosmology segment was a separate video. If you haven't checked that out, please do so. It featured the cataclysmic variable HD 283750, a BY Draconis variable. So again, check out yesterday's cosmology segment, youtube.com/smashamash/playlists. To find our whole video list, it's youtube.com/smashamash/videos. And that's today's cosmology segment. We integrated it. Let's talk about electrons. There are a bunch of them surrounding planet Earth, and they aren't sufficient to be charging up satellites. There's the graph of that. Here's a one-year chart from Solon.info. We're seeing low levels of electron flux, and they're going to get even lower since the coronal hole wind stream is arriving. So here is the 3-day chart. Expect this to be cratered over the next day or two. We can expect the forecast. There's my forecast. It's going to be a little bit lower than the NOAA forecast. No big deal, although we expect a little bit additional chaos as a result of that. Here's a diagram of the Van Allen belts, and here's the total electron content forecast, showing you electron density for the whole air column. Don't be a hole. Know what's going on in the whole air column. A little bit of chaos there as we see less organized Van Allen belts and indeed electron densities with low levels of electron flux. It's something common to coronal hole wind streams, and it gives us insight into the Earth's magnetic field because electrons are much less massive than the rest of the objects floating around out there. If you even want to call them objects, I won't get into that. That's for a different video as well. Here's a diagram of the atmosphere. Feel free to pause the video. Here is one slice of the atmosphere. It's the F ionosphere layer, which also gives us insight into the bridge between Earth and space. And we can expect to see some anomalies in this as well. And each color blob here represents vibrational frequency. And we're seeing some anomalies here in the northern hemisphere around places like North America. And this can affect things like the aurorae, where aurora borealis happen and where they don't happen, and so on. Let's continue on. Oh, here's the latest image, by the way. That's from 9 o'clock Universal Time. Things looking pretty normal there, although pretty low vibration, only making it up to barely 8 megahertz there over, I don't know what that is. That's China, I guess. The Korean Peninsula. And here come bonus features, but before we do that, I would direct you to our playlists at youtube.com/smashamash/playlists. Otherwise, you may not see our meteorology segments, which we just recorded live to twitch.tv/smashamash. All right, so here come bonus features, and we've got very old ground-based hydrogen alpha imagery here. I don't know what's up with that. 15 hours old. It's okay. So let's look at Lermonth here. Lermonth only 3 hours old. And you can see some prominences associated with sunspot 2842. Quite a bit of filamentary activity down here. We are listing no coronal mass ejection watch for the Earth-facing portion of the sun. And here's the GO16 SUVI thematic map. You can see some activity up here. That's part of the coronal mass ejection activity there. Either a collapse or an ejection of a major prominence. You can see that collapse happening there. A great reason to check the thematic map on the regs. It's almost like cheating. It's practically too good. The GO16 SUVI thematic map. A new feature to the daily space weather videos. Next, the latest high-resolution intensitygram. We showed the refresh on purpose so you know that it's the latest data. There's sunspot 2841, still beta class, still looking like it's degrading, as it's been slowly doing since yesterday. Sunspot 2842 also looking like it's shrinking a bit. Here are the magnetic fields. There's 2842. Again, alpha class. Sunspot 2841, still beta class. Barely. Still does have the capacity to perhaps produce a C-class flare. We'll close things out with the 171 angstroms SDO imagery. And we'll shrink it down so you can see the whole disk and the time date stamps. Anyway, thanks again for tuning in to the Daily Space Weather. Congratulations on realizing our channel exists, and may that solar wind be at your back.